Welcome back, friends. In this one, we're going to take a look at doing this graphing exercise. Please remember, on this channel, I post mathematical content of a more advanced nature in algebra and calculus and so on. All right, so here we're going to have f of x equals the absolute value of x minus 1. How do we do it? Well, big brace, and then we're going to apply the meaning of absolute value. That says whatever this is right here is going to copy it at first. And this, we write the condition, for example, that says that whatever this is, like the absolute value of x minus 1 is greater than or equal to 0. Then you take that same quantity there, but then you just drop the outside bars. So let me be clear, right? Which bars did I just drop? I dropped the yellow bars from the outside, to be clear. And then that's going to give us the negative of the absolute value of x minus 1. So I'm dropping the yellow bars and just writing this expression within parentheses, but negating here, right, with a negative. And this will be applicable when whatever this quantity is, like the absolute value of x here minus 1, is less than 0 this way. Now, we can continue here. So, of course, the first line can be recreated as absolute value of x minus 1, and we'll say that absolute value of x, so just add 1 to both sides, is greater than or equal to positive 1. The bottom line, so here what can we do, right? You can distribute this negative over to each term within the parentheses. So that's going to give you the negative of the absolute value of x plus 1. And then here, we're going to have the following, just add 1. So that condition becomes the absolute value of x is less than positive 1, this way. Now that we have it recreated in this form, we have to be, again, a bit more careful still. This part of it right here, right? That's an inequality in itself. So when is this true? This is true when x is less than or equal to negative 1, or x is greater than or equal to positive 1. We'll have to combine this with this. All right, friends. When is this part true right here, right? So this is true when negative 1 is less than x, which is less than positive 1. And again, we have to take this and combine it with this somehow. That's our goal here. So let's do that. We're going to focus on this part first. Why? Because on the number line, this is the part that comes first, right? So think of a number line, okay? All right. So this is negative 1, our first value. And we want to study, in other words, decide what happens, what does the graph look like for these values of x right here. Okay, on the left. So this is negative infinity, of course. So let's do that. Well, if you grab any value from here, then this part of the graph right here, the absolute value of x minus 1. If you grab a value of x to the left of or equal to negative 1, then this part is negative, isn't it? That means when you do the absolute value, you drop these bars and you multiply by negative 1. In other words, it's going to give us here a giant brace this time and just handle this part. So I'm going to go with this condition first. Just when x is less than or equal to negative 1. Begin with that. That means here, drop these bars and multiply it by a negative 1. So you have negative x minus 1. That's your first line. Now you have to handle what happens between negative 1 and 0 right here. Why? Because you see, that's present as part of this inequality here, if you think about it, right? Because this says negative 1 is less than x, which is less than 1. So to break this inequality down even further, right, this piece, that could be negative 1 is less than x, which is, say, less than 0, like that, you see? So we're going to look to see what happens over here. Just so we are going from left to right in that sequence of steps. So we know it's going to be this piece here. Now we're going to study this inequality. When x is between negative 1 and 0, then this right here, what happens? Well, the absolute value of x, how would that work? When x is a negative number, because it would be between negative 1 and 0, that's a negative number, you would drop the bars and multiply by a negative 1, correct? But that negative 1 would get multiplied by this negative 1. Therefore, in the end, you would end up with x plus 1. So we'll do that over here. We're going to have x plus 1, and this will correspond to the case when we have negative 1 is less than x, which is, say, less than or equal to 0, this way. I'm taking the less than or equal to 0 here. Why not? Okay, that's a little bit arbitrary. I could just as well take it, when, for example, 0 is less than or equal to x, less than or equal to positive 1. Not too important. Okay, So logically speaking, we pretty much have this part handled now, so that's done. Let's handle the part that goes from 0 to positive 1 right here. So this is a positive 1 right here. Now here, whatever x you choose, it's a positive value of x. It's still governed by this inequality because of this. So now look what happens to this part of the graph, right? If x is already a positive number, then the absolute value means you just drop the bars and then you just multiply by this negative that already exists. So that gives us the following then, that negative x, let's see, plus 1, and then you would say this is 0 is less than x, less than positive 1, this way. Now for the last part, the relevant part is going back to here, right? This is done now. So check mark for now, check mark, check mark. Now we have to see what happens over here, okay? Again, here, x is already a positive number. That means it would be governed by basically this, x is greater than or equal to 1, which means when you look at this expression right here, the absolute value of x minus 1, what would you have? Well, you would drop the bars and x is already positive. You would just have, in other words, x minus 1. That's it. So you would have x minus 1, and this would be for x is greater than or equal to positive 1. And we've taken our original expression and we've made this beautiful piecewise defined function out of it using this process of reasoning. What do we do from here? We just do a graph. So let's do a graph, right? That's the whole point of the exercise. Okay, so this is it. This is this. This is this. This is our x. This is our y. Let's do a nice picture here. So let's focus, say, on this piece here. That's just a negative x, but the minus 1 means that it's been moved down 1 unit. So for example, like if x is negative 2, it's negative of negative 2, which is 2 minus 1, which is 1, and so on, okay? In other words, this piece when you graph it kind of looks like this, but you got to stop right there at negative 1. All right, then the x plus 1, this is valid between negative 1 and 0. Like for example, when x is negative 1, this is 0. When x is 0, this is positive 1. So that piece is kind of going to bounce back to here, you see? So this is, say, x equals 0 right there. And then let me be clear, right? This piece here, it extends forever going this way towards positive infinity, okay? Now look at this negative x plus 1 between 0 and 1. So let's say this right here is x equals positive 1. Y is 1, so we are here. And when x is 1, then it's negative 1 plus 1, which is 0. So that means the piece looks like this. Right? And this here is y equals 1. And then for the last piece, when x is greater than or equal to 1, well, think about that. So like when x is 1 itself, then this is 1 minus 1, which is 0. So we are again here. And then when x is, like, for example, 2 is 2 minus 1, which is 1. Right? Like if the x is 2, then it kind of looks like this. And then because x continues forever, the graph just shoots off in this direction towards positive infinity. Let's see. That's pretty much it. So friends, if you like mathematical content of a more advanced nature like this, please be sure to subscribe to this channel, like this video. I'm going to be posting more videos. The way I generate the concepts for my videos is I look at books and places like that, and I just look usually towards the bottom of each question section, and they have more interesting questions than the routine ones that have already been discussed in great depth on YouTube and other places. Thank you. I'll see you in the next one.